Al, you're muted, Al.
So I am. Hello, everyone. That also bought me some time to hopefully share my slides.
Have you
hopefully
got
you can see my slides.
Yes.
Okay. Hi, everyone. Good to meet you all. I'm Al Cook, a fellow of the IET, but one of the activities I'm a participant in, and I'm saying it like that for a reason, is providing advice to the Centre for Protection of National Infrastructure, one of the national security organisations. And I was asked by them about 5 or 6 years ago, before the National Infrastructure Commission report that Matthew mentioned in his talk. I was asked to look at how to secure something called building information modeling. And some of you on the call will know quite a bit about building information modeling, how to use information to design, create, and even make use of large bits of infrastructure, buildings, bridges, roads, stuff like that. And I really didn't know anything about data modeling at that time. But what soon became obvious to me was that in order to address the security of information, we really needed to understand what that information was and how to address managing security required a degree of consistency. And it wasn't until I met Matthew a year or two into my work that I started to understand that there was a way of addressing it. And it essentially is covered by the layers in today's 7 circles of information management and relies on 4-dimensionalist work. So I'm going to talk to you a bit about how to address this through activity and process modeling. And I've got lots of diagrams in some slides, and sorry, there's a lot of text in this one, but I thought it might be useful to have a record, because Wendy mentioned drivers. What are the drivers for doing something different? It'll be quite familiar to most people on the call that there are lots of information failures around. It is really hard making use of data today. In fact, a lot of data today really doesn't get used much, or is really quite complicated to make use of. And I was going to read out a bit of a quote from a very what would normally be called a dry document, a Public Accounts Committee document from 2019, but it really does sum up the challenge. I'm not going to read about anything else on this slide other than NASA at the bottom as well, just to reassure you I'm not going to be reading from those really quite lengthy reports. But poor quality data management in government leads to failings in services provided, poor decision making, and an inability to understand how best to improve. Issues with data come up in many of this committee's reports. Over many years, government has increased its use of technology and data. However, departments have been left to develop their own processes for managing data, leading to inconsistency across government. Data has not been treated as a valuable asset, so it has become normal to work around poor quality, disorganized data. A step change in the government's approach to data is long overdue. Now, that is dated from 2019. And I'm hoping that today's event is part of this step change, which will turn out to be quite a long step and probably quite a high step. But nevertheless, it's worth doing, because all of these topics that I list here are really begging for making better use of data. And because this is an event hosted by the Newton Gateway from mathematics, I thought I'd mention only one of the other reports. NASA, an organization that's been in the news recently from some luckily very spectacularly successful work getting a small helicopter to fly on Mars, they have taken a long view on what systems engineering is to them. Systems engineering is a staggeringly complex and large activity for not just NASA, for lots of big organizations. And they've published some work that I would really recommend you looking at. And the links are provided in these slides if they're made available after the presentation. But they've actually gone back to some really fundamental topics, and they've landed on, firstly, in their long report published last year, a life cycle view of systems engineering, which isn't new to the systems engineering community, but they're trying to step back further from it. And I would really think that matches what we're recommending for the 4D community that we're building to the 4D community is, and the techniques that I'm talking about today really are based around looking at the life cycle of things. Matthew's layered slide showing that material things are generally composed of things that have longer life cycles than them themselves. So, and the NASA report also draws out that inconsistency is really a costly thing to the systems engineering community. Now, importantly, NASA doesn't address ontology and the use of integration of data. And I think we've got something to offer communities like that too. And we're making some approaches to engage with communities like this. But really importantly for the maths community, NASA have really got gone deep on the use of category theory for their emerging systems engineering work. And I think there is some promise for the foundation data model work that we're doing under the National Digital Twin program to map nicely to the category theoretic work being taken by NASA and others. I mean, these are big community activities and there's a long way to go with it, but I just thought that it would be useful to draw out something that is in the pure maths realm, and some of the theory that we talk about today looks rather pure, but actually I think we have a lot to gain by trying to harness those things together for our
Al, just so that
actual
you
work.
know, just so that you know, you're sharing the presenter view.
Oh, I don't know how to change that. That's okay. I will carry on. I will carry on with it rather than faff and try to change that view. The beauty of modern multiple desktops. You'll be able to get everything, and the slides are available afterwards anyway. And you can also see what's coming. I don't have many comments. None of them are rude. So the next point is, how do we make use of all of this theory? Matthew mentioned about information supporting decisions. I've got a list here of things that are, I think, are obviously relevant to the National Digital Twin. It's not an exclusive list. But one thing in common with all of these things is they're all activity-based. Systems engineering I've already mentioned as being activity. Construction, an obvious thing. Risk management is an activity that requires information about all sorts of things in order to make good decisions about management of risk. And if you look at a lot of these things, these overlap in their interests. The same people, processes, organizations, locations, environmental factors, and things like that have are relevant to many activities. So the way of, and Matthew mentioned activity in his presentation, the way of addressing this is to take a close look at activity. And I'm going to walk through some activity models to show how decisions can be identified and information requirements can be developed for them. And I'm going to draw your attention to some links that will be shared during or after this presentation, where I've written a document on how to go about doing this. And I've also written a draft methodology that can help people apply these techniques that requires the 4D commitments. It requires the use of better techniques for sharing the reference data, that is the extensions of the root commitments in the model, and that allows more consistent data sharing and ultimately data integration if we look at what we want to achieve under ambitious programs like the National Digital Twin. But what I'm talking about here applies in any context. Okay, I will then return to my very noddy diagram, which was meant to be a light-hearted introduction to activity analysis. Sorry for the interruption to the presentation. So the the activity examples that I gave on the previous slide that all involve huge numbers of decisions presents a massive information systems challenge. And we'll all be familiar with information systems that don't work well together, that seem to go through the expense of modeling things that are of relevance to multiple systems, but they model them independently. And the approach taken in the IMF is to enable them to be modeled in the limit once and be reused. And the goal is therefore to get consistency across whatever information interests there are in the participants of those life cycles, wherever and whenever they happen, to support whatever decisions are needed. Now, I mentioned that I'd been invited to look at the challenge of securing building information modeling stuff. An obvious challenge in that is also not to share what you don't intend to share. Not to share things that are not in the commercial interests or the national interests or the personal interests of those involved in various activities. And so to lead on to some very simple activity analysis, looking at the activity of brushing one's teeth, or my teeth this morning, that is a relatively private activity to me. It's also missing a requirement. I don't actually need any information about it. I've got enough myself. But from a 4D analysis point of view, we still have activity. And what we have is a number of things involved in that activity. I'm involved in it, particularly my teeth. They're part of me. My toothbrush and some toothpaste that is transferred from the tube, and some of it is used on the toothbrush in order to brush my teeth. But if I had a requirement to have information about that, I'd really need to know what it was. If I was looking at dental practice, if I was a toothbrush manufacturer, all these sorts of things, they will then allow the focus on the right parts of the activity, possibly more things involved in it than just my simplistic view here, but they can always be represented. And you'll see through the diagrams that I'm using here that I'm drawing heavily on the use of space-time diagrams. And this really does allow us to reveal quite a lot about things that are involved in the activities of interest. And when we're looking at large systems, we then have the challenge, how do we go about addressing activity? When you look at, from the discussions about three-dimensionalism earlier, it can very rapidly become ambiguous. When is stuff happening? Well, what does it relate to? Particularly when the activity relating to, and I've got a spatio-temporal representation here of an airport, something that's rather large and complicated, but the activity relating to the life cycle of the airport in this case will precede it by possibly decades, possibly many decades. Yet we're still referring to something that the intention is for it to exist in the future. So therefore, during its early activities, it is a possible existence in the future, but it will, and hopefully at some point, become an actual existence. And this also relates to some of the topics that Matthew covered about things like possible worlds. So I thought, well, what about trying to develop an activity model? I don't really like some very simplistic examples and assume that they can translate easily to the more business applications. And for the document that I'm sharing today, I thought I would pick something that we can all relate to, but it's relevant to the building information modeling community, relevant to the built asset sector, and relevant to better decisions. You may be aware that in the news a few years ago, actually it was about 2016, some school walls in Scotland collapsed. One particularly big one in Edinburgh, I think in about 2015, collapsed. And it resulted in an inquiry. And the inquiry found very clearly, just like the opening slide that I had with a catalogue of failings of decisions or the need to make better decisions, the inquiry found that there had been a staggering failure of quality management. And a lot of this involved little to no information. So I thought, well, let's go through. We've got a real decision that we would like to make. How can we improve on the process of getting better quality walls in Scottish schools, any schools for that matter, and how do we have information used in doing that, and have information records that demonstrate that it's likely that the quality of these walls has been improved. So I have a number of diagrams that show how activity modeling can be used to create a representation of what it is that's going on and what's involved in the activities of interest. So in this diagram, I have a built asset system, a school, with something that at some point has a new wall as part of it. Of course, as it's being built, that wall is being created, but at some point it will be deemed to be complete. Prior to that, there'll be all sorts of things involved in the activity of constructing the wall, the purple dotted diagram here. Of course, it doesn't take long to identify that I have probably missed quite a few things out of this diagram. And this is, I actually think, one of the benefits of doing activity model is that it effectively it's self-limiting, because as when we talked earlier about data systems having arguably more data than is necessary, and the data isn't used much, we should really be focusing on data that we really need. And an interesting thing that happened during the review of the document that I created was that one of the comments from one of the reviewers, I think he's on the call now, and I think it was a really good comment, which I would like to highlight here, which is, well, the walls that he had been involved with didn't particularly map to this particular activity. There were similarities, but there were also big differences. And this is the point. We should be able to model particular wall activities and model what it is that we want relating to particular walls. If we are making a wall for a proton beam therapy facility in a new hospital, that will have an awful lot of extra activity and participants compared to a brick wall that I may wish to commission in my back garden. And so we should be trying to not generalize too early. We should be trying to model what activity is relevant to our particular walls of interest, if we are interested in walls, and it should be generally applicable to anything. And of course, when we're looking at activity, the purple dotted line in the last slide, it turns out, oh, well, there's quite a bit more going on, quite a lot of other activity that's relevant to our brick wall. In fact, in order for our brick wall activity to create the brick wall, we need a lot of prior activity to design, specify, approve, select resources, procure resources, deliver resources. All these things are activities, and it's a lot of the same materials are involved in those activities. Those participants themselves, and you'll start to realize when I introduce this presentation, I mentioned my participation in providing advice to CP&I. We're all participating in activity. We're participating in the activity of this presentation at the moment. So if we look back at the life cycle of each activity and forward, we can start to identify where decisions either need to be made or will have been made that may be relevant to the activity of interest. And when we look back far enough, we can start to see that, for example, the bricks in the wall of interest weren't the component parts, were just raw materials. An activity happened that resulted in bricks being created. And sometimes that can be a key event for which information is created and needed further on. Are there enough bricks available? When were they made? Were there any certificates produced that warrant the quality of the bricks? What about the product data going along with those manufactured bricks? All of these sorts of things are relevant to our future brick wall if we need them. So this results in a surprisingly simple pattern. And I think a lot of the challenges with using 4D data models become easier when the patterns are identified, and by doing real analysis, and analysis is a really important activity in itself. I would really recommend that people view analysis as an activity that has participants that are being analysed, and that we want to take a lot of care. In fact, if you look at some of the examples on the opening slide, a lot of them involve really detailed, in-depth analysis, but they are stymied by the quality of data at the input. The quality of that data is about the things that are participating in the analysis, because the analysis activity needs them. But this simple anatomy of an activity illustrates that we really can reduce it to looking at participants that are needed and involved in the activity. It may be involved in, for example, a brick wall. It may be that we need an environmental condition that is suitable for that construction activity to take place. For example, we may need it to be above 5 degrees C or whatever, so that our mortar can set properly. All these things may require decisions and indicate the material participation in the activity itself. So the next thing is, well, there's one thing knowing what it is that we might need. How do we go about identifying the information that is actually required? And that requires a process itself. We need a methodical approach that allows a customer and supplier to agree a requirement. There's no point in having a requirement that nobody else is going to agree to, or that they might naively agree to and then subsequently find they can't meet. Both things are going to result in mistakes, which is a data quality issue in itself. So the process of coming to an agreement requires us to have a good way of identifying the requirements and exchanging them. So I've come up with a relatively straightforward process that enables us to do a mapping, identifying what the information is in the decisions, and a mapping to the formal model that we are creating to enable this consistent representation in data of the things that we are interested in. And the mapping activity is something that is going to be a vital element in the adoption of the IMF, because we want, this is effectively at the boundary when Matthew said we're creating the IMF, but we need people to be able to adopt it and use it. And I will hope that we get some involvement in that, in the review of this methodology as we create the foundation data model. And my hope is that we can create a standard around it, which also addresses one of the comments that I inadvertently bumped off the question queue earlier by trying to answer it, which was about how to learn from one of the previous integration data model activities that was done in the oil and gas industry that Matthew mentioned earlier, ISO 15926. And this model, mapping model, mapping activity should really help. So part of the mapping, if you remember the extensionalism comments earlier, draws on a firm footing in set theory, in what it is that what membership do the spatiotemporal extents that we are interested in have. And I have some beautifully simplistic diagrams here that only one on sets and only one on parts, but the David will be expanding on the reference data library and its role in setting up the shareable basis for good, trusted definitions of sets that we can use within the IMF. But what we need to do for in information terms is be able to specify the set of suitable bricks so that we can select our actual bricks that we want in our brick wall from them. And as we've seen in the space-time diagrams, we also want the parts of the brick wall to be, and the information generated about those parts to be also available to us. So we have the actual parts and the characteristics of them that are defined by their set membership. And some of these aspects become very clean to define and use in information terms with the 4D constructs that we're building the foundation data model on. So I thought, well, how can we illustrate a little bit about how we make use of an integrated model, talking about set theory and part-2 and composition and things like that can sound quite simple in some terms, but if for those who have taken a deeper look, they can rapidly become complex. And the foundation data model itself will at some point grow to a level where it is complex in itself, particularly with reference data. But if we've got a secure enough foundation to it, then we can be confident that we have a sound enough basis on which to use that information, as long as we know how to apply it. And so I plotted Matthew's high quality data model as a node edge graph here, just to illustrate what I've shown in the previous 2 slides is a very simple set of distinctions between sets. I'm including sets and relationships here, and spatiotemporal extent. Just a simple node edge graph. And in fact, the backdrop to my video image here is also a view of part of that graph as well, just to illustrate that they are named. And when you view the relationships in the model, you can then start to see the alignment between sets and parts, and set membership between states. Everything on the right here is effectively the types of spatiotemporal extent. And on the left-hand side of the node edge graph here, we all have all of the sets. And the membership relationships show the linking between the states, the spatiotemporal extent types, and the sets that go with them, that define the set membership. And then the part-2 diagram here shows as those set membership relationships removed, and the part-2 relationships, which effectively show largely down here, and I will not go into the detail of some of the others on the left here, how the part-2 relationships appear in the HQDM data model to show how things can be composed of parts. And that it results in a very clean basis on which to construct a rather large and complex model based on these integration data modeling principles. So because my presentation is about life cycle and process modeling, I thought I'd return to the challenge of doing large scale system engineering based on life cycle and process models. And people naturally think of process models as things that they have to follow. And generally, these are business process models. Business processes are things that are often created, can be a bit of a pain, but are there to help a consistent approach in business to doing certain activities. It just so happens that in a large system, that can be an awful lot of activity. And the document that's being released today shows a sort of a helpful approach to setting a context for doing life cycle information modeling, and information management is an activity throughout this in itself that can be applied generally to large systems that are of interest to the National Digital Twin Programme and to CP&I, who have an interest in securing them. So I'm going to draw to a close relatively soon. I'm not sure how much time I've got left actually, but the good news is that by having a consistent basis on which to go through analyzing activity and identifying decisions, and then using an information model to define what the specifications are for those information requirements, which is this slide here, we can then have a good basis for then storing, managing, querying the information and testing whether it can meet those requirements, specifications. A requirement is just the goal to have something actual, often in the future, or to check whether the thing that we have meets their specification for the thing that we were trying to create. And being able to codify the requirement specifications is a really powerful thing that we are ensuring is a key part of the foundation data model. And this is a long-term goal of the likes of NASA, the likes of the building and construction community, and the large-scale engineering communities worldwide. And a lot of investment has been put into trying to do this via other methods in the past, and a lot of the difficulties creep in when consistency can't be maintained. So the big challenge with all of this is that we want to ensure that we have a secure approach to it too. And the promising news that I would like to raise with this presentation is that by having a consistent basis on which to identify information requirements, we have a consistent basis on which to identify information security requirements. Information security and securing information itself is just part of achieving required data quality. Losing data is not a sign of quality. It can lead to all sorts of incidents and things that are regrettable, from reputational loss to the potential for even a cyber attack, for example. Things like that are undesirable activities. So losing data is just a data quality shortcoming. As I said earlier as well, risk management is a type of activity, and that requires good decisions. We need information for that. So identifying the information for risk management activities is also well worth doing. Generally, it's about having information about stuff that is already involved in plenty other activities. And so if there are those of you on the line from the information security community or cybersecurity community, then you will be familiar with things like role-based access control and attribute-based access control. And it's interesting if you read some of the authoritative guidance on it, so NIST's guidance to attribute-based access control, and some of the more recent papers. So the original author of role-based access control in the 1990s released a paper in 2017 about relationship and attribute-based access control. Consistency is assumed in a lot of these models. In fact, consistency is often left to the system owner or those involved in doing the design or commissioning of systems. But without having a methodology to go about identifying what it is that's required and consistently representing them, it is very difficult to apply these attribute-based access control mechanisms. And I would like to.
I'm so sorry to interrupt you, but you've got 5 minutes of questions.
That's fine. That's fine. I've got one or two slides left. So I'll just suffice it to say that the point about information security is one of my main reasons for pursuing the use of 4D within the National Digital Twin Programme. And if anybody's interested in looking at how the methodology that I've proposed here can be used for information security, I'm more than happy to speak to them during or after today's event. The methodology itself is composed of a number of diagrams, a number of steps, and I will just summarize here that it turns out to be quite a apparently simple looking set of steps, but those steps map to a model like Matthew's high quality data model, or the foundation data model that we're in the process of creating in the National Digital Twin Programme. And I'm happy to encourage people and help people have a go at doing that. And I'm following the methodology draft at the moment because I really do think it needs people to have a go at doing it as part of quality improvement of the methodology itself. So I'm not going to read my recap slide here, but I'm happy to stop there. That is my last slide, and take any questions if that's appropriate. And I'll apologise for any shortcomings in the faff with getting the slide in the right form.
Can't see any current questions at the moment. Does anyone have anything to quickly post in the Q&A? I mean, I guess if in retrospective people have something they want to post, I think Al could probably still answer you directly in the Q&A if necessary. But I can't see any more that have been posted in here.
So it was either really clear or it's quite a lot to take on.
There's one just come in here from Drago. The agents participating in an activity may be subject to deontic logic.
That probably requires a shall I respond to that in the comments afterwards? So a lot of this, if that means looking for either contradictions or things that are or aspects that are orthogonal to ontic aspects, then I agree that there are considerations that need to be made. One of the really interesting things from a security point of view is being able to not just check that what you've defined as being a requirement is satisfied, but that things that are being either analyzed or stored in a system are actually what was intended. And that can be my speculation is that it can be a tractable activity to undertake by use of a consistent data model that we've got here. But I'll take a look at that and respond a bit later today.
Yes, that would be good, because Drago has then gone on to say permissions, rights, obligations, but we sort of run out of time. Perhaps just one very quick thing here. Gerhardt has said, will this activity analysis, etc., be published? Methodology be published?
Yes, it will. And I'm sharing the draft today with everybody on the call. It can be shared widely. It's marked draft.
Okay.
And the document is already published as a URL on the CDBB website for the document too, as well as it being shared in the links today.
If you can put that in the chat afterwards, Al, the link to the document.
I think it's already there.
Okay, great.
But it's certainly with the Newton Gateway 2 for sharing. I'm more than happy to discuss that published material and to talk about how to go about applying it using the methodology. Yeah, the methodology is there for people to use now, but it is draft.
That's great. Thank you so much, Al. I think let's leave it there because we've only got a short 15-minute break, and these virtual events are very intense. We understand that. So we come back at 11:35 with the talk from Ian and John from Telesynth. So we'll see you in 15 minutes.